The next thing I want to look at is a very specific type of word problem that involves a common log. And these problems, quite frankly, are going to be some of the easiest problems you're ever going to deal with. They're to talk about the Richter scale. You've probably heard of the Richter scale before and how it measures the intensity of an earthquake. So it does involve common logarithms when calculating the value on the Richter scale, the intensity or magnitude of the earthquake. Now, the formula to get that value that you hear on the news is the common log of A divided by T plus B, where A is the amplitude of the seismic waves of the earthquake itself, and they're measured in micrometers. But this is how much the ground moved up on a wave of the earthquake. Now, the capital T is the number of seconds between successive waves, so between when the ground moved up and it moved up again. B ends up being an adjustment factor that's brought into play based on a couple of factors. The most important factor is how much earth is between the epicenter of the earthquake and your measuring station, wherever it is that you're measuring these seismic waves, because quite obviously the seismic waves are going to dissipate a bit as they go further out. If you're 100 miles from the earthquake, you're not going to feel it nearly as strongly as if you were right there on top of it. So this B value helps account for that difference there. Now, the problems that we're going to deal with, let me get this all on the same screen here. You're going to be asked to find the earthquake's magnitude on the Richter scale if the recording station measures an amplitude of 300, 2.5 seconds between waves, and B is 4.2. So literally all this question is going to be is plugging numbers into your calculator. Because you're going to say it's log of A was 300, T was 2.5, and the B value was 4.2. So you're just going to literally plug those numbers into your calculator. I'm going to move that over a little bit so we can see the problem still. And so you're just going to type in log of 300 divide by 2.5, end my parentheses for the log, but then plus 4.2. So this was a 6.3 on the Richter scale. Now this is, quite frankly, a very easy problem, but I want to talk about this so that we can sort of start to understand the Richter scale, and we can start to understand how intense an earthquake is and the difference between, say, a 6.3 and a 7.3. Because some people might say, well, the difference isn't much, it's, a sixth higher is all it is. But the difference between a 6.3 and a 7.3 is actually 10 times stronger. Because think about how you graph logarithmic functions. In order to take one step up in the y direction, you need to multiply the x value by the base, which is 10. So that means in order for our Richter scale to go up by 1 unit, the argument, or what I plug in, needs to be 10 times higher. So what's the difference between a 6 and an 8? An 8 is 100 times stronger because it's 10 squared. The difference between a 6 and a 9 is 1,000 times stronger. So hopefully this starts to make some sense when you start to hear about some of the world, famous 9-point whatevers that do such incredible damage and cause typhoons. You can start to understand, oh, even though a 9 compared to, say, a 5, where a 5 is bad, if I compare a 5 to a 9, that's 10,000 times stronger. It sounds like it's maybe not quite double the strength, but obviously it's not. The amplitude is much, much different. So that's why I want you to see how to understand a common logarithm. And so when you start to see things that are based on common logarithms like the Richter scale, you can start to get an appreciation for them.